How are we doing about the inverses? Everybody feel okay? So what was the key word from inverses yesterday? Switch, right? So if we have the data, if we have x, y coordinates, we just switch them to graph the inverse. If we have an algebraic expression and we want the other inverse, we switch the x and y and solve for y. Everybody feel comfortable there? Okay. Well, that inverse is important because now as we get into our next section, which is logarithms. Okay. So, and logs help us with some other things. So today, we are going to work on writing in two different forms. One exponential and the other is logarithmic. Okay? So we're just going to be going back and forth between these forms, between exponential and logarithmic. Okay? Nothing real earth-shattering here till we get into the next section. But if you jot one thing down, logs are in your, help us solve for unknown exponents, okay? So an exponential equation might be 5 to what power equals 25. Does anybody think about that? You can do that kind of mentally, can't you? 5 to what power would be 25? It'd be what? It'd be 2, right? 5 to the second would be, okay? So that's exponential. We're going to turn around and write it in logarithmic, which would be log base 5, 25 equals x. So those are the two forms. One's log form and one's exponential. So in algebra, we're adding a lot more letters now, okay? If you have your calculator handy, you can look at it. There's an LOG button, okay? That's our log. That's our base 10. It'll do all base 10s for us. For example, if we didn't know what 10 to what power equals 100, you can do that one mentally, can't you? What would 10 to what power equals 100? 10 to the second, okay? You can put this in logarithmic form, which we'll practice. I'll show you here. That'd be log base 10 of 100 equals x. Now, when we have base 10, we don't really write it because base 10 is the common. So don't get used to that, but you could go ahead and you have your calculator handy. It does base 10. Just do log of 100. Log 100. And what do you get? You should get 2. Okay? So I'll put that base 10 back in there so you can understand it a little bit. But that basically, logs will solve for unknown exponent. Here's your unknown exponent. I write it in log form, and now I can solve. Make sense? Okay. What do logs solve for? Unknown exponents. Eventually, we'll learn how to handle them. Right now, we have to learn to be able to go back and forth between these types of log and exponential. Common log is base 10. And that one is in your the button in your calculator, LOG. LOG is base 10. Like in that, we don't really write base 10. If there's no base written, then you know it is base 10. This is it for today. Maybe jot this down because this is it. We're going to go back and forth. Here is your exponential form, and we're going to be able to write it back in log form. I'll let you give me a second to look that over. I color coordinated it a little bit. Actually, I cut and paste that from somewhere else, to be honest with you, so I'm not gonna lie. Most students do okay with this, and then they think they get it really quick and they think, oh, I got that. I really want to encourage you to practice the problems tonight and get this first skill down, okay? Get this first skill down. It'd be like, you know, the first thing you gotta learn before you do a sport. If you're playing the guitar, you gotta learn how to do a chord, right? Before you gotta play that first note. Basketball, you learn to dribble before you can get out there or something, you know? So this is our first skill that we need to get. Now, a lot of times these will be just some true statements. You might have base 5 to the second equals 25. Is that true? 5 to the second, is that 25? Well, sure. Now we're gonna write it in log form, okay? It would be log. Notice that 5 kind of goes just a little bit below. 25 equals 2. That's all we're doing. Fun. Good stuff. Boring math. Yep.
First period looking at like really grub. I'm trying to teach us math first period. We're bored out of our minds.
Hey, would you do the ACT?
Screw you, I'm not doing that.
Do it yourself. All right, let's take a couple practice here. Da-da-da-da. See if you can just do the first one and stop. That way we can check and make sure we are all on board. Ready for the first one? Write it in log. It would be log. My base would be 3. 243 equals 5. See if you can maybe jot down those next couple. Just practicing, going from what? We have exponential. We want to go to log. I think this one's messed up, really. It should be the half, should be with the 25. So this should be 25 to the half equals 5. All right, so this one would be log. Base 25, 5 equals half. This one's a little different, so watch it, this one. This would be log 10,000 equals 4. Notice I did not write what? Base 10, because we understand base 10 is just base 10. Don't write it. How we doing? Is everybody okay? This would be what? Log base 636 equals 2. And my final would be log base AC equals 3. That's an A. Now, it doesn't seem like much right now, but we have to be able to go back and forth between these two things. And right now you think, oh, I got it. But you need to practice a couple tonight on the homely work. Is that fair? Everybody got it? The homely work will take you not long. It's pretty quick. And we want to just practice that. All right. Note takers good? Knock out a couple more for me. Yeah, just trying to practice. We have an exponential. We're going to walk the logarithmic. Yeah, this is wrong. but. Letter B is wrong. It is 9 to the third is not 27, by the way. So, anybody have a calculator? Put 9 to the third for me real quick, see what that is. 729, yeah. This should be 729, and that would make this 729. And this last guy would be log base x. So think about this last one right here. Any exponential, okay, I don't care what it is, it could be 100 to the 0 power. What is it? 1, okay? So anytime we have anything raised to the 0 power, that's equal to 1. So everybody okay there? Exponential log. Let's try a couple the other way now. I'm going to give you a log, and now try to write it as an exponential. So now I have them as a log. Now, most students do better this way. It seems easier. Going log to exponential seems much easier because it just seems to be staring at you right there. Your base of 9, 9 to the first is 9. 2 to the 9th is 512. Three to the second is 8. See how I switched that from my 8 here real quick. See that? Our last one, 4 to the second is 16. The anything to the 0 power is 1. Roger, Roger, everybody okay? Questions or concern there? All right, just gonna go back and forth between those two today. A couple other properties that we want to discuss, and one of them is we just kind of had it there a second ago, and that is the base. We just had this one right here. Log of 1. Anytime we have a log of 1, okay? So log base B of 1, okay, it'd be like reading it in exponential, okay, base to the 0, base to the 0. The second one is unique. This one here we're going to use often. So anytime we have log base 5, that is 1. We could have log base 13, that is 1. We have log base x, that is 1. Does that make sense to you? So if we get the base and what the log is the same, that's going to be 1. Because think about that exponentially, what would it write? What's log base 5 would be what? Exponentially, log base 5 would be 5 to the first. Would be 5 equals 5, so it's always going to be 1. We need the right one because it's not. So even if this was x, okay, it would be 5 to what power equals 5. So we get the same base and log. It takes some time, okay? It's quite different. It's a little bit, it almost looks like a little bit of a foreign language, logs, okay? But you will be fine. Common log. No base is written for the log with a base assumed for 10. So, for example, log 5 is really log base 10, 5. Okay, so write that in exponential. Let's write that in exponential. It'd be what? Yeah, we can go ahead and say x is out here. So it'd be 10 to what power equals 5. That's kind of funky, isn't it? What's 10 to the first? 10. Real simple, 10 to the first. What's 10 to the 0? 1. Anything raised to 0. So we know that x, if we were trying to solve for it, it'd be somewhere between what? 0 and 1, right? Okay, it's gonna be probably an odd number. How about, someone try 10 to the 0.42 in your calculator. 10, raise it to the 0.42.
2.63.
Oh, so we need bigger number. So we need bigger. 10 raised to the 0.73. Let's try that. We're trying to get 5. You see what I'm trying to do? I'm trying to get 5. 5.37. So it's lower than that. So 10 to the 0.68. No, I went too low. So it's somewhere in there. Okay. All right. Does it make sense what we're doing here? Okay. Now, try in your calculator now. Okay. Put log 5 and see what you get. I'm listening. Log 5. Point what?
698.
Keep going.
9,
Uh-huh.
7,
Uh-huh.
0,
Uh-huh.
0,
Uh-huh.
0,
Uh-huh.
4,
Uh-huh.
3.
Uh-huh. Okay. Do you see that, folks? What kind of number is that? One of those numbers that keeps going and doesn't repeat. What do we call them? The most famous one of them is called pi. What do we call those numbers? Irrationals, right? What is that? What is 0.69897? That would be, okay, 10 raised to that power what's it gonna equal? Come on, somebody, impress me. What's it gonna equal? It is gonna be 5. Is it gonna be exactly 5? Maybe not. Might be 4.999 because we're working with what kind of numbers here, ladies and gentlemen? Irrationals. What do logs solve for? Unknown exponents. Now, sometimes you might want to try to do a little mental math. So set this equal to x. Now, those of you who've already got things figured out, you can do this one right in your calculator because it's base 10. What could you put? Log of what? Log of what? It's base 10, so log of 0.01 should get you the answer. What is it? Log of 0.01. Somebody, come on. It should be -2. That's right. So let's convert this to exponential. Can we convert this to exponential? What's my base? It's not written. What do I know? Oh, it's 10 to what power? It's 0.01. Well, the calculator told me -2. So let's see. 10 to the -2 is like 1 over 10 to the second, right? Getting rid of the negative exponent. Oh, Mr. Crow, do you expect me to remember math from last month? Yeah, we do. Which would be equal to 1 over 100, right? And that's a fraction. Is that the same as that decimal? Uh-huh. Uh-huh. What do logs solve for? Unknown exponent. What's the one log that does in your calculator without any problem at all? Base 10, which fits the common log. Common log. Base 10 is called the common log. Uh-oh, not base 10, but let's rewrite it. Think about it. Rewrite this in exponential. Rewrite it in exponential. what's it gonna be? 5 to what power is 125? Can you do this one mentally? That's what we're looking for. It's an even number, isn't it? It wasn't an odd number like I gave you earlier. We were trying to get to 50. What is it? 3. Okay? 5 to the third is 125. Now, what's the problem here? It's not base what? Not base 10. But there is a method of doing it. I'll show it to you right now. We're gonna get into it later. We're gonna call it change of base, but I always like to show it to students right away, even though it's not in this section. Grab your calculator. Try log of 125 divided by log of 5. If you get brackets here, you'll have to close them. You should get 3. That is called change of base. So not only can we solve for log of base 10, we can solve for other base 2 by doing this method. Did you get 3? Watch your brackets if you gotta close those. All right. The reason we can solve is because these are the inverses of each other. Okay, y equals 2x and y equals log 2x. Those are the inverses. Remember from yesterday, that's how that allows us to be able to solve. Their domain and range get switched. Their x and y's are switched. Inverse, the big question was switched. Just make sure you're aware of that. Not the end of the world. I've already gone over this base 10. You can get right in your calculator. So we are going to move forward and just work on a couple of problems in your homework tonight. Thanks for your time and your effort today. A beautiful day to be at Lake High School.